Welcome, everyone. My name is Frank Crawford. I am the Education Committee Lead for Passive House Alberta, and welcome to this month's Passive House Alberta Coffee Talk. Today we'll be hearing from David Campbell, who is the Director of Development and Construction for Homestretch Development Corporation, and David Walker, who is the Account Manager or Unaccount Manager with Independent Supply Company, or ICS, in Edmonton. And ICS is the local distributor in Alberta for the Tosot brand of cold climate air source heat pumps. Jerry Wagner, who is the VP of Business Development for Tosot, unfortunately had another item come up, so he's not able to join us today, but in his place we have David Walker, which is excellent. And both the Davids will be talking about or using the T5M Connect North Glenora FIAS certified missing middle 16 plex building as a case study on where they use the cold climate Tosot brand air source heat pumps. And with that, David Campbell, you have your slides up. So why don't you tell us a little bit more about T5M Connect North Glenora?
Hey, thanks, Frank, for the introduction. I don't know, there's not much more to do to introduce myself, so maybe we'll just introduce the project team, architect, energy modeler, mechanical engineering, and we did some mechanical design assists, mostly because it was the first high performance building that I had worked on, and we wanted to make sure we got the mechanical right from the beginning. Um, we kind of had this goal that we would build a passive house multifamily residential building, and we would show how it could be done and how it made sense to build to the standard, and that we would encourage other people to, learn from what we did. We wanted to do some learning ourselves and kind of inspire these types of buildings to become more common. Um, Yeah, so as Frank mentioned, it's a 16 unit building. It's on two Edmonton lots. Um, each lot was 58 by 120. So two standard residential style lots. We did a rezoning. We did a rezoning and this is kind of this is what we came up with. It's a big mix of unit types. The smallest units are one bedroom, 600 square foot type apartments. And we have some, two bedroom in 1,000 square foot size apartments. We have some two bedroom townhomes, and we have some 3 bedroom townhomes. So it's a really big mix, and it's kind of organized around this central courtyard between the two buildings. It's built to the Paschal standard. We just received certification from BS. Um, and I guess the other thing that's important to note is that it's an entirely electric building. So no gas line to the building, all electric heat. And the way it's metered is like individual meters for each unit. And then there's a solar PV system on the roof, and that makes it makes 10 of the units net zero. So we didn't get all the way to net zero, but we probably got about 80% of them. Um, so we have the air source heat pumps. We have two different systems. So, and on the main floor, we have bigger units. These are the bigger 2 bedroom apartments and the townhome styles. So in those units, we have like a ducted heat pump system, which is the bottom left picture. You can see it installed. So that is ducting, warm air into into all the or into all the rooms. And then we have a bunch of kind of like smaller units on the lower floor, and that is where we're using the ductless system. So that's what you see in the center picture. So it's like a one ductless heat pump in the living room, and then a little bit of electric baseboard heat, which is the right-hand picture, in the bedrooms, just to make sure that we have even distribution of heat. But the idea for those units was like, hey, let's put the ductless heat pump in the biggest room where like most of the energy is going to be used, and then just use a little tiny bit of electric resistance in the basements. So one thing to note that's I think pretty important is we have a little bit of redundant electric resistant heat in the lower units. But the upper units, the bigger units, there's no electric resistance back. So no backup heat source. It's only the air source heat pump. There's some cut sheets of what we ended up using if you're interested in the details, and the other Dave can probably talk more about that than I can. And here's a bit of a picture of the central courtyard, and on the right hand side here you can see these are the outdoor units for the lower units, and up here these gray ones, and in the center these are the outdoor units for the upper units. As far as functionality go, I mean, I think everyone knows we had a massive cold snap in January, and certainly at that time I was nervous about how the building was going to perform. But I did check in with the tenants, and this is a completely purpose-built rental project, so it's all rental. And I did check in, not with all of them, but with a number of tenants over that cold snap, and the feedback I got was that the units were 100% perfectly comfortable, and there was no temperature drop at all, actually, even when it was -40. So I actually don't know if it's because the heat pumps continue to function and provide heat, completely during that period, or just if the envelope was also so good that, not much heat was lost for that period. But I suspect it's actually a combination of both. Was that, Frank? I think that's most of what I had to say. Is there anything you'd like me to add?
No, I think that's perfect for now, Mr. Campbell. So you can end your share, and Mr. Walker, you can tell us a little bit more about the Tosots, and then we can always come back with questions in the chat box. So yeah, so if you have any questions, put them in the chat box. I had about 16 questions already sent in, and I'll kind of look through them all with the new ones that you guys come up with right away. So, Mr. Walker.
Hey. Welcome. Thank you for having me today. And as Frank mentioned, I'm account manager with Independent Supply. I'm actually based here in Edmonton. We also have another branch in Calgary as well. I've been representing the Tosot brand for close to 3 years now. And I was one of the skeptics when I first started of heat pump in our climate. How does it possibly work? How are we getting heat out of a -30 air? But I've been converted. It's been a sort of a pleasure working with these units, because we don't get the callbacks, and I love hearing the stories that they've mentioned there, that he checked in and they worked through those cold snaps. I'm sure he was one of the many that were hesitant and waiting for that call of something's gone wrong. But yeah, over 3 years we've had very, very few issues. The units are all rated for cold weather climate. Where they were developed is they are a Chinese product. But they're from northern China, so their climate is actually very, very similar to ours. And their big focus was to get off of coal heating homes, and so they wanted to actually really focus on the heating side of things, which was a nice change from a lot of manufacturers where you mention -30 and they don't really know what you're talking about. So on the T5M project, we're very proud to partner up with and assist Renew Engineering and work with them during design. Dave mentioned about it worked at -40, and tenants were happy. The units do still operate below -30. We just don't have published rated data past -30, but they'll still keep going and going and going. You just lose capacity the colder it gets. So yeah, typically on the design front, if you're not going with a backup form of heat, you design the size of the unit based on the heating capacity at design conditions, which for Edmonton's -30. So yeah, that's the option. We mentioned the two different styles. The ducted unit is very much like the indoor unit looks more like a split. Well, a typical furnace type installation. You can get this with an electric resistive heater that gets mounted in the top of the unit. Like in the T5M case, we didn't go down that route. But one nice thing with these units as well, like you see on the cut sheet there, it says 24 volts controls compatibility. That means we can use basically anybody's control. It can be, if you want, you've got an owner that likes the Google Nest or the Ecobee or a Honeywell, whatever. There's no proprietary controls on this. So yeah, any 24 volts heat pump compatible thermostat works on the system. Some of the other design considerations, it does defrost, so you need to allow for condensation coming off the bottom of the unit. We can get a fair amount of ice buildup. So I know on the T5M, they've basically built a ice dam or an ice well underneath the units, just to give that allowance for the condensation's got something, or condensate's got somewhere to go. Yeah, that's the basic unit. If I scroll down, they are very quiet. Like as you can see, they're rated at 57 dB, but that's the 3-ton unit. Personally, I think they're a little bit generous, I want to say. Like all the installs I have seen have been a lot quieter. So yeah, noise is really not an issue on these things. Like we're rated to -30. Small footprint side discharge, which works great on infill projects and where developers are building closer and closer to the property lines. Side discharge is actually becoming more of a positive thing. Variable speed fans at a variety of different speeds and pressures. As I say, we do have the optional electric heaters if needed. If the system's all designed properly and it's a high efficient construction, as we see in this case, the electric heat's not necessary. So yeah, and then you have like the split, very similar. Again, low ambient conditions. These units are more of the traditional wall-mounted things suitable for smaller applications. Downside of this for residential applications is you can't introduce outside air into the system like you could with a more traditional ducted system. So that's just something to take into account. Both systems are R410A. They are going to be moving over to the new A2L refrigerants sometime next year. but for present, we're all R410A, and while they're moving away from 410, it's still going to be around, and parts and stuff are going to be available if needed. So yeah, that's the general thing. I know there was some questions about capacities and stuff. So we do have, based on your indoor temperatures, heating and cooling capacities with the COPs. As you can see, amazing COP performance, especially at minus 30, minus 40. Right. All these units are inverter driven, so it's not like the old days where you had like a single stage unit. So it's like jumping in your vehicle and you're at a stop or you're at 100 going flat out. So these units ramp up and down depending on what you need at the time. So yeah, that's basically my bit, unless people have got questions and want to know more about the systems.
Thank you. All right, we got a few questions. So I guess to start, maybe talk a little bit about maybe from the design side, when you would kind of select either a ducted, fully ducted system versus a mini split unducted system, kind of what type of building layouts or designs kind of better fit one to the other. Oh, and you're muted now.
Yep. From a personal point of view, like I used to be an engineer, so I can talk from that sort of side of things as well. I was a mechanical engineer for a number of years before moving into this side of things. Typically, if you're tight in space, you would go with the mini split option. If you're only running refrigerant lines around, you need a lot less space. However, in a larger home where you're trying to serve more areas, I would typically go with more of a ducted system, just so we can have that movement. We're serving multiple areas at the same time. So,
okay, and I guess a follow-on question to that. I believe at T5M you had fully separate ductwork for the ventilation and the heating and cooling. Do you normally do that, or is there a way to integrate the heating and cooling into the ventilation ducts, or kind of what are the design considerations between those two options?
Well, actually, I was thinking about that when the other day was talking, because in T5M and the upper units, we have like the ERV fully ducted into every single room. But it seems to me that we could have saved a lot of time and effort just by ducting it into the heating distribution system. So maybe David can talk about that.
yeah, I've seen it done both ways, where you're providing sort of outdoor air through an energy recovery ventilator for the space, and I've seen that both ducted to all the spaces, but I've also seen it ducted into the return of the heat pump, much like you would in more traditional furnace system. You would duct it into the return to the furnace. There's pros and cons. It gives you that advantage that you can then temper that ventilation air that's serving the sort of coming off of the ERV to whatever you need before it actually gets put into the space. The downside is you're not necessarily putting that outdoor air into the spaces that most need it. So it's 6 of one and half dozen of the other.
Yeah, I think I've seen that as well, is that yes, there is no hard answer on whether separate ventilation or combined ventilation is better or worse. I think in T5M is where you had a very small footprint, ducting the ventilation separately didn't cost you much ducting, and that, I guess that's more ideal, because then it's fully separate and you can control each one as you want. But you can often get cost savings by combining the ductwork for larger houses. You talked about the refrigerants. So I guess, does Tosot have an air to water heat pump option? And I guess what type of applications can that equipment do? And is it the same performance specs down to rated to -30 and kind of anecdotal performance below that?
Okay. Yes, we have like what they call it. It's a monoblock system. It's a air to water system. It is rated to -25. And so yeah, I'm a little bit wary in our climate for these type systems, because you are running a supply and return water line out to this unit that's mounted outside. In our climate, we would have to go with a glycol mix to avoid freezing everything up. And as with any glycol system, you lose capacity. It's about 15% derate for glycol. At the same time, you're increasing your pumping costs, because glycol mix is harder to pump. Then when you drop below -30, you're going to have to put in additional controls and safeties just to avoid. You don't want that thing shutting down and freezing solid. So we do have options. If anybody's interested in an air to water type system, we do have other options available, where it becomes a refrigerant system running to inside, and then we can provide a refrigerant to water system inside the building. It gets around that running glycol lines outside in the middle of winter. That's the bit I'm sort of slightly hesitant on at this stage, but I know it's becoming a hot topic at the moment.
Yep, tricky, but I guess can be done. I guess this one might be a trickier one, and you might not have the answer. Do you know if Tosot or any of the other cold climate brands are actually getting performance data below -30, or are we so small of a market segment that it's not worth the testing cost?
At the moment, I don't believe anybody is. From my understanding, AHRI are going to be pushing more for for testing at lower temperatures, to get your AHRI certification. However, I think everything's a little bit on hold at the moment, just with the change from 410 to the A2L refrigerants. There's a lot of moving parts at the moment. So I see within a couple of years there's going to be testing data at least to -30. So it'll be sort of official independent testing to -30. It's not available at the moment.
Fair enough. Mr. Campbell, maybe a bit more back to economics. So you have done, I think, some fair amount of economics review. I guess, can you talk a little about maybe just to the cost premium is what we always like to say. Is there a cost premium to go high performance, or if you look at holistically, is that cost premium valid? And then did you look at the cost premium versus natural gas versus heat pumps, kind of just some of the economics picture of that one?
Oh yeah. So we did a ton of research and study, but it was 3 years ago, and I can't remember all of it. But I remember that when we looked at the whole life cycle, it totally changed our analysis, and what we decided was the best option. And because this is a purpose-built rental and not planning to be sold, it was really important to us to look at the life cycle. So if I remember right, in a year one cost, just cost to install, like the gas furnace was by far the cheapest. But it had a couple of disadvantages, and one was that it didn't have air conditioning, and this building being passive would overheat like crazy without air conditioning. But as we started looking into like a 5 year or a 10 year, or I think we did a 25 year life cycle analysis, like it became that the air source heat pumps actually became the cheapest. And I think when we add to that the solar PV on the roof, it really started to make a big difference. Right, I can probably share after the fact all that analysis, but I'd have to take some time to dig it up if you want.
And actually, I believe a few years ago, we did another Passive House coffee talk with you when you went through that initial analysis. And I think you looked at like 13 different wall assemblies and a number of different mechanical systems. So I believe if you go to the Passive House Canada YouTube site, that webinar is recorded and posted there.
We're also like a demonstration building for SSRIA. So if you go to their website and look around there, you'll find all that information there as well.
Yep. And I believe there's also a few questions about the WUFI model and Passive House International Standard versus Passive House US Standard. And I believe you touched on all of those topics, I believe, in the SSRA webinar. So I think look at those ones to answer those questions, right, David?
That's right.
Sorry, just looking at some other questions. So I guess so another question, what type of system can be used if you want to use, I guess, in-floor heating? Do you have to do an air to water, or can you use the air to air and somehow get to an in-floor system?
For that, if you wanted to go in-floor heating, your two options would be going air to water, or you would have to go with an electric resistive underfloor heating system. The air to air type system, sort of, I guess you could be blowing warm air underneath your floor, but it's not really a recognized system.
Okay, I guess another question about maybe switching to retrofits. So if we're looking at kind of a deep energy retrofit and replacing the mechanical systems there, Mr. Walker, do you have any kind of recommendation on what's the simplest option, or the options you can use for retrofits?
Yeah, retrofits becomes an interesting area. It really comes down to the homeowner and whether they want to turn around to ATCO and say, please come and pick up your meter. We don't want it anymore. If you want to go like that full electric, then you can replace your existing furnace with the Apex unit and look at going fully electric. The other option is you stick with your furnace option, and we can go with it looks like a typical coil on top of AC coil that you would see on top of your furnace. And we can hook up the unit to a coil on your furnace. So you can then use the Apex system for your first stage of heat, and then you've got the gas for when it gets really, really cold. That gives you the advantage then. You can size your outdoor unit more based on your peak load. You don't have to worry so much about that -30 condition. And so yeah, you have a full variety of options there.
Okay, but with retrofits, reusing the existing ductwork is most often the most cost effective than trying to put mini splits everywhere.
It's definitely more cost effective because the ductwork's already in place. So
yeah. I guess a little bit about warranty. Hopefully we never have to call for warranties. So since Tosot isn't the most recognizable air conditioning brand, you said it was made by someone else in China. Who is the warranty with? Is it with Tosot or is it the actual manufacturer? Or maybe talk a bit about warranties and what's available.
Yeah, it's like it's actually a very, very good warranty on these things. We have 10-year warranty. Like Tosot itself is a brand of Gree, who are actually the world's largest air conditioning manufacturer. So there's many other badges that get put on this unit, and with a variety of different suppliers. So yeah, there's a lot of variety there. Unit comes with a 10-year warranty, and the only issues we've typically seen have been typically due to installation errors. That's the one thing with this style of system I do recommend is make sure it's installed by a proper contractor. I love going onto Amazon these days and you search for cold climate heat pump and you can find your install it at home option that you can buy off of Amazon. And typically these are the ones that the contractors then get all the calls back and give cold climate heat pumps a really bad name. It's just something to bear in mind. Do you really want to put your home heating in the hands of a home install? And because when something goes wrong with it, like we stock the parts. You trying to return something on Amazon, it's not going to be a quick fix.
Yes, excellent. It's always the combination of the equipment, the service, the warranty, and the price. You need actually all four of them. And one, if you miss one, then it doesn't always work so well. So yeah. I guess, Mr. Walker, since you sell different brands, we are talking about the Tosot today, but I guess how does the Tosot compare to some of the other cold climate heat pumps? Like there's Daikin, there's Mitsubishi, there's Arctic, there's different ones like that. Do you have a preference? Do you like all of them? They have different advantages?
Like I try and keep up to date with all the other manufacturers. Like everybody's getting a lot better at their cold climate and cold climate heating. And that's one of the things I've been trying to do with a lot of engineers is educate them that when they're specifying this stuff, they need to specify cold climate heating. But also when you're looking at the different specs, things to consider is compare the capacities and the energy inputs at the same temperatures. So you should have them all rated for at least minus 25 Celsius. Compare those capacities and the energy inputs at minus 25. Look at what controls options are available. I know certain manufacturers, you have to use their controller, like their thermostat. Some of those thermostats are $300, $400, $500 because it's got a name on the thermostat. I like ours because you can use anybody's. So it comes down to a personal preference then for the homeowner. But yeah, all the major manufacturers are basically catching up, and so yeah, it's they're much for a muchness now. I like the Tosot just because we've got a proven track record. We've got now, I would say, over 300 installed in the Edmonton area. So, and have been installed for 3 or 4 years now. So,
Excellent. All right, I guess another question back to retrofits. So when we are doing the retrofits, and if we're doing what's called, I guess, the dual fuel or the hybrid system, where we have the natural gas and a heat pump, is there a certain, do you set up the controls that they both work at the same time, or even if we have the heat pump and electric resistance, how do you set up the controls? Do they work at the same time? Do they turn off? What's kind of that kind of design thinking for those systems?
typically we have it set up so that the heat pump works to a certain temperature, and then it'll flick over based on the outdoor air temperature. It will change over to the furnace system when it gets colder. The Enercan website has a great program that you can use. So everybody's gas and electricity rates are all over the place at the moment. So if you go onto their website, there's a little calculator right there, and it'll help you work out exactly what temperature is economical to run your heat pump, and then when to change it over to your gas then becomes the cheaper option. I've seen that the numbers, depending on what people are paying, it could be -5 Celsius is the economical cutoff. I've also seen it at -15 is the economical changeover point. So everybody's got different power rates and gas rates. So
Excellent. All right, another one maybe for Mr. Campbell. So you've done this one project. This was your first high performance one. Are you working on additional ones, and are you sold on high performance? And are you going forwards, or I guess what would you tell to other developers that are thinking of either dipping their toe or moving to high performance? What would you tell them, I guess?
I'm completely sold on high performance. I don't know exactly what the standard is. Um, will we do another passive house certified project? Maybe, maybe not. But certainly we're going to take the best of what we learned and incorporate it in the next project. So we are working on something new. We're working on actually two projects that we're expecting to be completely electric and utilizing air source heat pumps. So the first is an 8-unit building. It's much the same as half of the T5M Connect project. We're designing it right now and into development permit, and hoping to use actually completely the ductless heat pump system. It's mostly smaller unit, so that's that project. We're targeting net zero. I don't think we're going to certify to passive house, but we may still. And then we're also working on 4-story apartment, small scale, 23 units. And the intention is actually to use air source heat pumps in their entirety. So to answer your question, yes, I'm completely sold. Sometimes I'm working on, what I would call like a conventional building with a conventional envelope and a natural gas heating system, and kind of wondering how long that's going to be in place until we're ripping it all out to change it to electric. So
Excellent. Good to hear. Another one for Mr. Campbell. Are you guys monitoring this building in any, I guess, shape of way, just to kind of see how the performance, if it's matching the model, or just how the energy bills are coming in? Or have been looking at the energy bills, and are you seeing drops in energy bills? Are I guess you renting the building any differently because the energy bills are less?
well, there's a lot of questions there.
Sorry,
Okay.
pick one. Pick your favorite.
I'll answer them all. So we are monitoring it. So we have, remind me of what we put there, Frank, because you suggested the
I
Imperium
believe
or
they put
something
in
it's called.
the Emporia energy monitors. So I think either 8 or 16 circuits are being monitored, as well as the mains, which gives us fairly good data from each unit. And then there's a monitoring for the solar. It would be separate.
Yeah, so we have Oh, sorry, I didn't mean to step on you, but yeah, so we have that. We have the monitoring for the solar. We have our electrical bills. We do know that for April it tipped over to being like net or like energy positive. So we're actually receiving money back from those units that are connected to the solar PV as of April. So I think we're watching it, but I don't think we have enough data yet to like give a comprehensive report. Like, is it actually using the amount of electricity that we expected it to, and how's it performing? You know, is it exactly the way it was modeled? Or,
Yeah, you only occupied
um,
it in October, I believe, is when the first people moved in.
first building in July and the second building in August. So it's coming up. You know, it's coming up to a year. But I think we were a little bit late getting the energy monitoring in and installed and commissioned, and we had a couple bumps getting it set up. So we only have like 6 months of data.
Yep, excellent. And I think so. I've been looking at some of that preliminary data, and one of the early conclusions is that fixed connection fees, even for electrical, when you get the demand down so low in high performance buildings, I think they were eating up like 50% of the bill was just the connection fees, something like that. So another thing to work about is trying to have fewer meters, more people on one meter, so that those fixed connection fees aren't as impactful. And I think last question, David, was about how you actually rented the building and kind of the financials, trying to recoup some of those savings from the energy efficiency.
Yeah, and that's a little bit tricky, and it's something I've learned a bit about. So the way, so I mean, the problem is that the owner spends a bunch of costs to make a really wonderful building envelope and probably pays extra money to upgrade to the air source heat pump, and then the tenants kind of get the benefit of that because they have lower utilities usages. And we typically see their bills for electricity. Some are down near $100 per month, and I think the 2 and 3 bedroom townhomes, which are the biggest units, are only a couple $100. So talking about a couple $100 for electricity and heat per month is pretty fantastic. The units that aren't connected to the solar PV, we just let the tenants get their own meter, pay their own electricity. Pretty straightforward. The ones that are connected to the solar PV, we charge them a flat fee of $200 per month for their electricity. And because those units are essentially net zero, we're using that $200 to pay for the solar installation. Looking at a couple different options for the next project. Actually, it seems pretty common to, or it seems to be becoming common to allow tenants to buy their own electricity and then export all the solar produced electricity right to the grid to recover those costs. So that's what we're looking at for the next building. Well, me and you've had some discussion back and forth on like, hey, is this actually going to work long term, and does it actually make the most sense to? But it does to me seem to be working out that way.
Yeah, there's you guys are kind of leading the edge, so it's yeah, we don't have great answers on what's the best way to do it. We're just looking at the different ways to do it. Back to Mr. Walker, what's the, I guess, the life expectancy of the Tosot heat pumps? Like if the warranty is 10 years, but you hope it lasts this long, or I guess what's the oldest one you've ever known in existence kind of deal?
That's the thing. It's a fairly new technology. 5-10 years ago, the technology wasn't there. But typically with any mini split type system, you are looking at a life expectancy of probably 15 to 20 years before it sort of is economically time to like look at replacement. The reason for that is technology is changing so rapidly. From like you go back 10 years, this technology wasn't even around. So where are we going to be in 10 years from now? I don't know. My crystal ball is broken. So we do what we can.
Yeah. Yes, if they warranty it for 10 years, then it should last at least that long, and hopefully at least 50 or double that length. All right, just looking through. So if you're in the chat, Alex from SSRA has posted those 2 other webinars that T5M did for SSRA. So you can grab that out of the chat and look up the other details. And I think we're actually getting fairly close to the end of the questions.
Yeah, I see there was a question at the start about the capacity
Oh, yes.
of a unit of -30. That I'm going to clarify that, like, that particular unit is mentioned there, the TUD30, is what we call the Apex Lite. They have a version of a Tosot that they paired off a lot of the ultra heating capabilities, more to suit the US market, where they don't have that -30 issue, and that is one of those units. So yeah, that's actually an Apex Lite unit. Those are only actually rated down to about -15 Celsius, so it becomes a little bit more. It's not the full-blown unit to get that cold climate heat. And where I mentioned earlier, it's like, make sure you're checking. So you're comparing apples to apples for performance data. That would be a perfect example where we have 2 Tosot units, both seemingly rated for the same thing, but one doesn't actually go down as low as the other. So there's a price difference between the 2. So
Yes, yeah, there's definitely a technological and price and performance difference between just a air source heat pump and a cold climate air source heat pump. That differentiator is important.
yes.
And those performance graphs, do they include the defrost cycle electrical heating of the pan in them, or is that separate
I
energy consumption?
believe it's all built into part of the cycle.
All right. Another question about wind issues. So do you have to be careful where you're putting, I guess, the outdoor unit, depending on if it's in high wind area or that you don't get snow, I guess, piling up against it?
You definitely want to keep it above the snow. Like, you don't want the snow piling up against it. I've never really seen an issue of like the wind. However, if it did become an issue, there are wind guards available to help it, but I've never actually had to use any of the wind guards in any of our applications. So
I guess same question. Do you recommend a roof over top of it, or have you not seen it needed?
it hasn't typically been needed. Sort of we see it with snow mounted on the top of it, and again, there's side discharge, so having a roof above it's not going to really harm it, but it's not something that's really needed.
Yeah. And I guess you want to make sure you're not restricting that flow, because it has to move a very large amount of air on the exterior to pull that heat out. So you don't really want to be restricting the air movement at all. A little bit about grants. So SEEP is a Clean Energy Improvement Program. Is the Tosot approved for those? And also, I guess, the Greener Homes Loan that is still around. Are Tosot and both of those approved for both those grants?
They are. The one thing to be careful of with the grants and loans and stuff, they have to be a paired and a matched system. So, like, if you're going for the retrofit, you have to get the certified coil that it's paired with. You can't just put in anybody's coil. While the Apex would work with any coil with a TX valve, you wouldn't be eligible for the grant if you put in the wrong coil. So
yeah, so both the indoor and outdoor unit have to be certified.
Yes.
Would you ever place the heat pump on the roof? So I guess your outdoor coil would be on the roof, or do you always want it to be more, I guess, accessible? Or what
We
locations can you put
started,
the?
Frank, we started with them on the roof of the T5M project, actually,
Oh,
because we didn't have a lot of space on the ground. But then at some point it became obvious that the line sets were getting too long and it was, um, but I'm super glad that we moved them to the ground because the idea of having them up on that roof and having to get up there to install, not install, but like, to do any maintenance or check on them or warranty or whatever, it would be a huge hassle. So I definitely wouldn't be looking at putting them on the roof of a building like this one. That's for sure. But I
yeah, and
think like commercial, multifamily residential, like um, there's often you'd probably find a ton of examples where you'd find them on the roof.
yeah. If you can provide safe access and maybe they're on the north side of the roof, so you're not taking away solar panel space, then and the line sets, yeah, aren't too long. I guess, Mr. Walker, is there a what's the distance that line sets, or is there an optimal distance that line sets are run outside or distance from the indoor to outdoor units, either elevation or distance?
The maximum elevation distance is 50 feet. Again, maximum total piping, so with supply and return of 100 feet. So we have few limits, but we've got good length.
And they're fairly well insulated, so I guess ideally
Yeah.
you want to make them inside as much as possible, but if they're all outside, it's not. Is there a big penalty hit or performance hit?
There's not a huge penalty hit. It's just typically if they're on a roof or something, they're more susceptible to damage, like somebody stepping on them or vandalism or whatever. So
Yes, they are solid copper or flexible copper, but yeah, they don't like to be stepped on.
no, especially when it's -30 outside. And
Yeah.
the other one thing I would sort of mention, if you're thinking about putting them on a roof, is to just pay attention to the when it's defrosting, you are going to get that condensate, and you're going to end up with likely an ice block on your roof. Just something to consider.
Yes, you're adding. Yeah, you want to make sure that water, that condensate, is somewhere to drain away.
Mm-hmm.
Is there much, I guess, with the placement of outdoor units, is there much of a difference whether or not they're on the south side or the north side? I guess some of the time you'd want the south side to get warmer air, and the other times you want north side to have colder air. Is there a preference, or it doesn't really make a difference?
It doesn't really make a difference. Like you're dealing with sensible heat, so it's not really a too much of a difference whether it's north or south.
Yeah, so yeah, wind chill doesn't make a difference. It's the actual air temperature. All right. It's getting to be last call for questions. We've actually got through a bunch today, so thank you very much, Davids. Lots of good information. Yeah, I think that's about it. We got 5 minutes left, so if there isn't any other questions, thank you all for coming today, and look forward to chatting with you at the next Passive House Alberta Coffee Talk.